arrived. The world is teeming with innovation as new business models reinvent every industry. InsideAnalysis is your source of information and insight about how to make the most of this exciting new era. Learn more at InsideAnalysis.com.
InsideAnalysis.com.
And now, here's your host, Eric Kavanaugh.
You're so glad you go there in your mind. Welcome to the future.
All right, folks, welcome to the future indeed. Your host here, Eric Kavanaugh, on the only coast-to-coast radio show that's all about the information economy. It's time for Inside Analysis. And folks, I'm pretty excited to be digging into the Wayback Machine today and stretching it all the way to modern times and beyond, quite frankly. We're going to talk about the mainframe. That's right. They're still out there. IBM still sells mainframes. The ZOS, it's still a very active part of our commercial world today. Lots of business processes run on mainframes all day, every day, and have been doing so for years, sometimes 10, 20, 30 years. Mainframes are alive and well. We've got an expert with us to kind of walk through what's going on in that space. Doug Johnson is from Rocket Software. Actually used to be ASG, got purchased by Rocket Software. I just learned that today. So these shows always teach you something, and we're going to talk about what's happening and why it matters. So mainframes, like I say, have been a robust part of our economy for 40 plus years, probably almost 50 years now. A lot of companies have been trying to modernize, but if it ain't broke, don't fix it. There are a lot of things that work very well on the mainframe, but the question becomes, how do you integrate mainframe technology with the rest of your stack? And what is this whole thing, the cloud, about? What about containers and Kubernetes and all that fun stuff we've talked about before? That's what we're going to discuss with our friend, Doug Johnson. Doug, first of all, tell us a bit about yourself and what you do in your job as you try to educate and do product roadmap stuff.
Thanks, Eric, and I really appreciate the time to share a little bit about what's going on that Wayback Machine. I like that. So good stuff. Yeah, so I'm Doug Johnson. I run product management in our data modernization business unit here at Rocket Software. And my job really entails working with customers, our account teams, and also the industry as large in terms of the future of what's happening with data and how it's being modernized in many different areas, including the mainframe. And so my team works on the roadmaps and works with engineering and customers. It's a pretty exciting place.
Yeah, that's good stuff. And when you're in product management, your main job is to really understand the technology. What does it do? How does it work? Where does it apply? And when you start talking about the roadmap, obviously you're trying to take care of customer needs. You're trying to augment what has already been built to handle new capabilities, for example. And you're, of course, in the data modernization space. And, there are 1,000 reasons for that, I'm sure. One, big data. We saw 15 to 5 years ago just dominate the conversations in our industry. Now there's more emphasis on AI and machine learning and things of that nature. But big data is everywhere now. It's not that it went away. It's just that we all take it for granted now. And that was one of the main drivers for this whole modernization concept, right? Is the fact that we went from relatively small amounts of transactional data to very large amounts of really machine data, like machines talking to machines, exhaust data, some people call it. But all these new systems that Google and Facebook and LinkedIn and these other companies have built, well, they spin out tremendous amounts of data. And if you can capture that data, marry it with other data, you can start understanding what's happening in your environment. Why are things going slow? Why are things working, et cetera? But that whole big data revolution, I think, really drove what is now called data modernization. What do you think?
Well, that's a great summary of some of the big trends that have been happening in the last several years. And with that, when it comes to topics around the mainframe, it's very interesting because what we really have experienced is a lot of customers have gone through, even though the mainframe has remained the same, over the years, the people who have been working with it and those systems and understanding what's even there and how it impacts the rest of the business is just not known. And so this idea of being able to see what is going on in your environment, but then also tying it to other business processes that you have and the data flows throughout the organization is a key problem customers have. And so that's some of the things that we do in our roadmaps is look at tools that can look at the code, look at the data that's in those systems, and then stitch it together to see the connections that are hard to see today. And it really helps as part of that modernization journey, go left, go right, tweak a little bit here or there. And if someone's looking for some key information, we can help you find it in terms of bringing it into those analytic stacks and other things. So again, the mainframe plays a very big role, and part of it is just really around having that visibility.
Yeah, and COBOL, right? A lot of mainframe applications were written in COBOL, and that was a problem for quite a long while, like the last 5 or 6 years or so. There are so many jobs for COBOL developers because guess what? The old apps were written in COBOL, and even though that's still the case, something called ChatGPT came along and may have helped out a little bit. I'm curious to hear your thoughts on that because a lot of people don't know ChatGPT can write poems. It can also write code. You can write in all sorts of different coding languages, not just human languages, right?
Yeah, it can do that sort of thing. The interesting thing is when you're talking about the mainframe and some of the critical systems that are existing in those environments, you don't want to enter a 3-letter prompt or just run it through your code converter and go, I think it'll be good enough for my customer critical transactions. So we haven't seen in this particular environment, we haven't seen the big push for that, although we're always watching that space in terms of things that we can offer customers. But the visibility around, for instance, running some tools against your COBOL program, understanding what those connections are, and then maybe where you want to put investments to make a change. So whether it be use some tools to help you migrate code or data in those environments, which I'm sure we'll talk more about the data challenges around that, but also just kind of those connections is a first step that we've been focusing on recently. Give you an example is, for instance, around someone trying to run a report against some critical information, and maybe the information exists maybe in the source from somewhere, and they don't know where, but ultimately it ends up in a BI cube or something where they're trying to run some reports. But when they do that, they find that the timeliness of that data is a good 48 hours behind what a business needs. And they want to see what is the source of this data and can I get that data faster? And so that's some of the things that we do. We help you buy back that time by getting visibility into where information might exist in the organization, including in the mainframe, baked into that COBOL somewhere. And so then you can go and look at some open standards to get that data in a more timely fashion.
Yeah, that's very interesting because to your point, there is an immediacy to business these days. You want to know what's happening right now. Knowing what happened 48 hours ago could be useful, but it's not very good for customer experience. It's not very good for putting out fires. So the question then becomes, how do you do that? And I guess what you're saying is you've got some tools and technologies and methods to help companies look into the mainframe that they have and kind of understand where the data is going in, how it's going out, when it's coming out. And you have other ways of accessing it and provisioning it. I mean, there are lots of ways that data is moved around. ETL was the bread and butter, still is, for many organizations, extract, transform, load. Then you're doing ELT, extract, load, transform, et cetera. There's data virtualization. A number of vendors have been in that space for a while. And what I'm hearing from you is that you're able to find ways to see into the environment and help the business understand where the data is coming from and then how they can expedite that process, right?
That's exactly right. And what I really like about what you said earlier about the ecosystem and the mainframe is really important because obviously the world isn't just one technology today.
Right.
It's a whole series of technologies. And one of the things that we really focus on is making the data that's permeating the entire organization, being able to see it and manage it, both for those use cases that I was mentioning around, for instance, reporting, but also very critically things like compliance or doing business change as an example. So if you consider, hey, there's a project we're considering where we want to change a system, maybe change a user experience, what impact would that have to other parts of my organization, including those critical information that exists on the mainframe and is managed in those environments? And that's some of the things that our technologies and some of the investments we've been making help customers really gain those insights to make a choice again on where to put their investments and what kind of impact analysis it might have in terms of that decisioning.
Yeah, and the impact analysis is huge, right? Because when you transform the business, that means you change something. These days, that means you're either changing code or you're adding code or you're changing an architecture, you're doing something new. And let's face it, there are lots and lots of shiny new objects these days. There are lots of new ways to get data. There's streaming with technologies like Kafka or Pulsar. You know, you've got Snowflakes of the world and Databricks and all these other amazing technologies that have come along to allow people to analyze data, but that doesn't change the fact that a lot of the data in the systems are still running on the mainframe. So coming up with that information architecture, that's the real key to success these days, and being able to see into these environments, do the impact analysis as you suggest, is crucial to be able to understand what you can change and how you can change it without breaking something, right, Doug?
Absolutely. And there are millions and millions of dollars, and then lots and lots of armies of people working at this. And so if you get it right or get it wrong, it's huge impact to a business. It can really make the difference between, are you competitive compared to what others are doing, or are you actually behind if you make the wrong choices? And that's what we really try to help organizations, is buy back that time and reduce that risk of some of that critical decision making. And, along the way, in terms of that decision making, what we also find is knowing the strategy that people have with the mainframe is really important. Some organizations say, hey, we have these critical systems, we've had them forever, we're going to keep building an ecosystem around it. Where some other customers say, we really want to have a strategy where we can take some systems as part of that and have a hybrid approach where we start moving some of that to the cloud. And then some customers are all in, where they, in a 5 or 10 year, 15-year timeframe, even in some cases, they want to have that trail map to perhaps move from what they have today to some future goodness that they have. And so that's a key area also in terms of that visibility that is critical to the overall corporate strategy and investment portfolio that happens.
Yeah, right. Well, and so we should appreciate the fact that mainframes work. And I can tell you, in the operations world, if something isn't broken, they don't want you to fix it. I mean, just generally speaking, leave it alone is their main message, because they're the ones responsible for it. That's where this whole business IT divide, I think, came from, was because the business wanted to change something. IT is like, guys, what are you talking about? We're having trouble keeping this running as it is. Don't complicate things, right? But then the cloud comes along and machine learning comes along and AI matures and all these things develop. So there's increased pressure on the business to change something. The key is, what do you change? And it sounds to me like you're offering a very positive service for being able to assess what is the current state. How are these applications running? If we change this, if we change that, how is that going to impact us down the line? And, no doubt about it, rushing to the cloud is not something anyone should do. You really want to understand, what are these business processes? What can we modernize? Where can we modernize them? And you wind up usually having a sort of layer of abstraction, right? Above the mainframe, but below the cloud or below the on-prem data center, the rest of the data center. You want these layers of abstraction where you can kind of understand what's moving where, and then make your changes in those environments that affect either upstream or downstream, right?
Absolutely. And as part of that layered approach that you were talking about, trying to really deal with a lot of the unstructured data that also exists elsewhere in the organization, including the mainframe, is really important. Things like customer statements or billing information, things that aren't very important to customers, right? So, and so as you go to look and modernize how you're doing that, you just really want to be very thoughtful, and you want to make investments that, as you, for instance, build out a new customer portal, or build out a mobile app experience. As part of that, when you have that API, that abstraction that you were talking about, you want to make sure it can get information wherever it may exist in the enterprise. And of course, that also includes the mainframe. But you don't want to put the burden on, for instance, an individual application developer to have to know about arcane formats, like AFP or whatnot. And so that's also what some of our technologies do, is we help you access that unstructured information, and we put it in a modern format on the fly, so that your application developers don't have to know anything. Matter of fact, what's interesting is people using our technology, in many cases, they don't even know what's on the back end from an end user perspective or an API perspective. And that fits very much into that kind of middle layer that you were talking about, to really help with that abstraction, where you don't have to force on a developer or an end user person to really have to know about that endpoint of where it comes from, that data.
Right. And, I'll throw out an interesting point here, just kind of an analogy. I just came back from ClickWorld last week, and they were talking about how they're moving to the cloud, click cloud, but they also were very careful to say time and again, we are not going to forget about all the on-prem installations that we have. So we're still going to be taking care of these technologies. We're still going to make sure everything works fine in that world as we encourage people to go to the cloud. And one of the key considerations is that with any sort of applications you've been using and gotten used to, if you port that to the cloud, usually what happens is you only port the bare bones stuff first. And then over time, you start adding features that were on-prem. And that's for a whole variety of reasons. One, dev time, just it takes time to do stuff, right? But the point being, if you were to go straight to a cloud instantiation of some data warehouse, for example, you lose a whole lot of context, you lose functionality, you lose things. And that's why you want to be careful about what you do here, because number one, to be able to re-platform or sort of re-architect, refactor a whole existing environment in the cloud is going to be really expensive. It's going to be painful. To do it even cloud natively, for example, it sounds good, but it's very difficult to pull that off. So I like that you use this term thoughtful to describe how your team should be as you look at your environment and figure out ways to go forward, right? You want to take time to do that, really document everything and test all along the way, right?
Yeah, absolutely. And what's interesting is organizations definitely need to take a very measured approach, but some organizations also say, we want to take a measured approach, but there's some footprint that we want to move faster, perhaps even away from the mainframe in some cases. And so the technologies that we've been working on really help you be able to move the data without reprocessing it to popular endpoints like, for instance, S3. And you can even do hybrid models where your processing still is done on the mainframe, but your storage is actually done in a modern fashion, like, for instance, like with S3 or something like this. And so what we find is it's really about the applications before and after the data that are super important. If you disrupt those thousands, millions of lines of code in many cases that are sitting before and after that data, that's where the real disruption that can happen. And so we've worked on a lot of tools that can help you mix and match a lot of these hybrid use cases with cloud. So it doesn't have to be an all or nothing. If your organization is saying we must move faster, we must do some digital change to change an experience or bring some data to a customer in a fresh way.
Mm-hmm. Yeah, that makes a lot of sense, because there are pressures to move to the cloud. There are lots of good reasons to move to the cloud. It's a fantastic marshaling area for functionality. It's a good marshaling area even for data, at least data that's born in the cloud. Now, taking a whole mountain of data from on-prem and pushing it up into the cloud, there are companies doing that. You have to be careful about how you do that, because you really want to understand your access patterns. You want to understand what people are doing with that data. How does it interact with your applications? All that stuff can be mapped out, and really should be mapped out before you ever try to pull something like that. Because if you go too quickly, you're going to have a very unpleasant rude awakening when it arrives. But folks, don't touch that dial. I'll be right back. You're listening to Inside Analysis.
Welcome back to Inside Analysis. Here's your host, Eric Kavanaugh.
Take us to the future.
All right, folks, take us to the future indeed. I want to go to the future where the systems are always running quickly. I never am on the phone with some customer service rep who's, oh, I'm sorry, our systems are running kind of slow today. I don't want that. Nobody wants that. You want stuff to work, right? That's what you want. You want to go to Amazon, buy stuff, go to some other site, buy stuff, and have it work and have it be seamless and quick and fast and secure. That's what we want. That's the good stuff. But you got to modernize to get that. You're not going to get that with some of these older architectures. And so I'm talking today with Doug Johnson, who is an expert in this space with Rocket Software these days. I love the name, by the way. How can you go wrong with Rocket Software? But we were talking about containers in the break there, and I'll just explain quickly to the audience, for those of you who haven't heard before, Google came up with this project called Kubernetes. If you ever see K8s, that's a sort of abbreviation for it. It's a container orchestration system, but basically it's sort of like a de facto operating system for the cloud. Now, Kubernetes does run on Linux, so that's the operating system that it uses, but it kind of operates like a de facto OS. And the best way I heard it described was by a girl in the open source world who said, look at containers as little boxes for system processes. So little things that your computer has to do, like open an application, or a lot of times I'll use a spell check as an example, right? You could use a spell check in Word, or you could use a spell check in Excel, in other applications. That's a service. The spell check is like a service. And way back in the days of service-oriented architecture, we had coarse-grained services and fine-grained services. It was the same general vision, but then Kubernetes came along and really kind of revolutionized how all that stuff gets done. So a lot of the new apps that you see out there, a lot of the cool new stuff that's happening in the world of technology is running on Kubernetes. It's everywhere now. They've basically won this whole shebang, and it's an open source technology. So you don't have to pay to use Kubernetes, but you do have to get people who know how to do it. It's not the easiest thing in the world to figure out. So there is obviously a cost to it in terms of deployment and management, et cetera. But it really has won the day. And containerization is a new way to do things. And the last thing I'll say about it is that what's nice is that because you've broken it into lots of little teeny tiny pieces, the big stuff doesn't break as much, right? You used to get sites that just crashed and didn't work. You don't get that as much in these new environments. What you'll get is one little piece of it that doesn't work. And then what they do is they kill that pod, basically. The pod just say, yep, kill that guy, we'll start again. But with that, I'll throw it over to Doug Johnson. Kubernetes is changing the world, but it's not the mainframe. And we have to find a way to get these two systems to talk together and to work together. And that's kind of what you guys are working on, right?
Yes, absolutely. And with that, there's a number of areas that our customers and we've seen in the industry in terms of leveraging the mainframe with Kubernetes. So, at the base level is we were talking before the break, we were talking about this kind of abstraction layer where you can access data. And so what we do is we create some of these pods that you were talking about that run in that Kubernetes layer and put a front end essentially in front of that mainframe and then provide all sorts of data services to that. So everything from just raw access, like we were talking about before, where it can convert formats for a developer or an end user, we can get access to information. But also if you need greater scalability, it can just create another pod and have that kind of level of scalability. But then there's also other things that happen along that same vein is within that layer is also where we put some protective services. So it's the mainframe or really any critical enterprise information, you really want to make sure it's thoroughly protected. And so we do everything from having a very strong access control layer that can even look at where you are in the world and determine whether you can access something, or even do things like redact information on the fly for you. So if you go to access some sensitive information, it can make sure that you can see certain information and then other persons see other information. And so those are some of the things we've been working on and customers are really enjoying.
Yeah, that's a very interesting comment you just made. There are new technologies that are coming out, technologies like Okira, and there's one called Immuta, and there's one called Prevacera, and there's a few others that have come along that are all about trying to protect PII, personally identifiable information, as it gets accessed by analytic applications, right? And or even AI, right? So you've got all these powerful technologies now, analytics technologies, but what data am I supposed to have access to? Well, I mean, in the old days, you could control that a couple different ways. You could control it at access at the database level, which is something you can do, but it's hard to manage at scale. That's the problem. Or you could govern it at the consumption layer in the app somewhere, but there was nothing in the middle or nothing meaningful in the middle. And that's all changing now, which is good, because what you want, and we're seeing more of this, are these sort of dynamic technologies for in the moment determining, well, should this person really get access to this information or not? And so you even see this with sort of ephemeral access, right? Like you get access for 30 minutes or for an hour or 15 minutes or something like that. These are all designed to protect the systems and protect the information, because we've seen, I mean, look at the Colonial Pipeline hack and how that took down the East Coast of people not being able to drive because they shut down the pipeline that delivers the gas, right? So these hacks are very, very serious. Ransomware is serious. There are all these different threats. And you guys are taking a pretty clever approach, it seems, to protecting that critical information, which is on the mainframe, right?
Absolutely, from encrypting it at rest to making sure in transit it's encrypted, but also going beyond and making sure, as we were saying, that dynamic way in which you access information. This particular user can see that, this particular user can see this other thing, including things that protect information and PI on the fly. And what's also interesting is we also do that with unstructured data as well. So when you kind of look at a system that already knows your data dictionary and you can see everything, oh, you know, this is a social security number, you know, this is that. That's one problem to solve, but it's another when you have unstructured information in a repository, you need to kind of cull through that, make some policies, and then dynamically apply them. Those are some of the things that we already have in market, and those are continued investments we're making. So it's a pretty exciting area, and it really helps make sure that an individual application development team or an individual user or department doesn't have to really take on the burden of figuring this all out. That can actually be done at a corporate policy level. And that's why customers really use our technologies is it really helps them really use data more as a service internally and not be afraid to use it. Some of the times what we've also seen is customers have lots of useful information, but they know it has they're not sure what it has. This is the problem. So there's this kind of trepidation. So it kind of comes back to those themes earlier about knowing what you can, where the information is, what those flows are, and then ultimately be able to put it into action, even with unstructured information, which is, again, an area we've been investing for years on. Pretty exciting.
Well, that is really cool. And one thing that gets me very excited about the modern information landscape is what you just mentioned, that you can do this policy management. Now, 15 years ago, even 10 years ago, and some would say even 5 years ago, policy was just something written in a document that sat on a shelf, and you had to hope that the employee read it and knew it and adhered to it, because there was very little that you could do in terms of dynamic policy enforcement. But now we can do that stuff. There are machine readable policies that can be implemented and protect dynamically against all sorts of things, even accidents, even someone accidentally accessing information they weren't supposed to. It protects us in all these different ways. That is a much different world than we grew up with. Like in the early days of the mainframe, you didn't have these sort of dynamic policies that you could define, manage, execute, and then monitor over time. Now we do, and that is a very, very big deal, right, Doug?
Yeah, absolutely. And it ties back to both protecting that critical information you have on the mainframe, but also it extends beyond. So the way we've implemented this technology is it works with your critical systems with your mainframe, and that's the bread and butter of what we focused on. But we also made adapters that tap into other systems, including other unstructured systems. So for instance, whether it be maybe a SharePoint repository, or where information might exist in other repositories in your enterprise. And we even have an ability for you to be able to customize it, because what we've also run into is we have large enterprises that they have some custom content system that was created years ago. And speaking of afraid of change, is someone's like, Bob built the system, Bob isn't here anymore. And, what do we do now? Right. So what we've been able to do is kind of put abstractions in front that allow you to get access to that information. But that policy, unified policy layer applies to whether it's be the mainframe or beyond. And so that can be really powerful, because again, what can happen is end users or developers just need one API or one user experience to access this information. And so they don't have to worry about, where it's coming from or what format it's in. It's automatically protected from them on the fly. And so that's some of the things that our customers have really enjoyed.
Yeah, that's a really good point. You mentioned this a couple of times, so I want to explain to the audience why you're doing that. The ability to make changes in your organization requires lots of different stuff, right? You need people who develop, you need people who understand the systems, you need to know what you want to change, get that from the business, et cetera. But the speed at which you can try things is really, really important for reasons of morale, for reasons of business acumen, and so on and so forth, for reasons of survival in some cases. And so what had to happen in the old days is there was a very long, what they call waterfall process that had to be followed to change anything. And we wound up wasting lots and lots of time because people weren't communicating properly. And it's just not a very efficient way to do. But now we can have this much more agile approach. And what Doug is describing here is empowering your application development team to really focus on business problems and not worry about the security, the compliance, all these other characteristics that need to be handled. That can be handled through the platform or through some of these policies. And that liberates the developers to try new things. It liberates the business to talk to the developers to try new things. That is absolutely crucial for digital transformation, right, Doug?
Absolutely. And what we've also seen is this becomes even more important when the stakes are very high. If you consider, for instance, a merger and acquisition type scenario, sometimes whether or not to do the deal is all dependent on how fast can we integrate our organizations. And, many organizations have these critical systems where they have years and years of data in the mainframe, and they need to integrate it into the rest of their ecosystem, again, to use that word. And so if you're trying to bring developers together to bring a unified experience to customers, the ability to do this very quickly can be the difference of, wow, that acquisition was really worth it. Our customers really see us as one company now. We're able to integrate business processes and be fluid. Or, sorry, boss, it's going to be another 6 or 12 months until that's finished, which, isn't a really fun conversation.
Right. No, you have to be able to move quickly. And that's really what we're talking about, is empowering your team to be able to make changes. First of all, understand what's there. I mean, that's one of the biggest challenges, I think. And we want to talk too about AI and how AI can come into this equation here. And bottom line is, you better be careful. I mean, one of the downsides, at least in the early days of ChatGPT, is that if you type in some of your proprietary code or some of your proprietary recipes or whatever, that's going into the machine, and it could come out some other side, some other place, and you won't even know. I think there's going to be some really interesting conversations to be had around that in the near term. But the point is, you have to know what's out there, know the steady state, and then be able to do that impact analysis you've talked about to try new things. You try it and fail. Fail fast forward is what they say, right? That's what you've got to do to be able to solve these real mission critical problems, is have the agility and have the confidence to be able to make some change and know that you can either undo it or at least fix what you've created, right?
Absolutely. And you started off this segment by kind of talking about the cloud and Kubernetes and different technologies around that. And what we've also seen is a lot of customers have really seen this kind of rise to microservice style architectures, where works very well with Kubernetes because it allows you to manage these different pods, like you were saying, and you might have dozens, hundreds, even thousands of them, depending on what happens. And what we've seen with a lot of customers is they really like these style architectures where you have these little piece parts, like you were saying. Part of it is because it allows you architectural purity of scalability and such, and that's a good thing. But the real reason is it allows the business to scale at a people level. And so it allows different developers to work independently of each other and build new business logic, create new business functions, and ultimately let the business go faster. But then you have two problems, or now you've introduced a new problem by doing that, is in many cases what happens is you proliferate the access of data. So in many cases, a development team will create their own database or their own store of where they're putting even unstructured data. And now what can happen is critical information can get out of sync with other systems through these kind of architectures. And so to remediate this kind of problem, we've looked at technologies that allow you to look at data quality across those landscapes. And so particularly considering, for instance, the mainframe as maybe a little bit the source of truth for many applications, it allows you to look into what's on the mainframe and then what's in other systems, and does everything match up? And this is very important in, like, for instance, reconciliation or financial use cases. And what we have is customers have used our technologies to make sure everything matches in real time as they're creating these microservices. And so it really allows this teams to kind of move very quickly, but at the same time, the quality teams and the infrastructure teams that want to make sure both quality is intact, but also compliance is intact. Really can enforce these rules. So it kind of gives you the best of both worlds through that approach.
Yeah. And what Doug is talking about here is the fact that at these larger organizations, you're going to have whole separate teams that are all important. They have to work together, but you can't have everyone in the same room all the time. So you have to come up with policies, procedures, technology stacks to enable this kind of collaboration. And then, to his point, you want to make sure that you're getting the latest data, the freshest data, the data that is accurate, because things change. And so that requires what really amounts to an information architecture, is what it boils down to, and kind of understanding where and when you can build in your checks and balances, where and when you can kind of bring in that last security check, if you will, to make sure it is secure, that last little bit. But don't touch that dial. We'll be right back. You are listening to Inside Analysis.
Welcome back to Inside Analysis. Here's your host, Eric Kavanaugh.
All right, folks, back here on Inside Analysis, talking with Doug Johnson of Rocket Software, all about modernizing the mainframe and really being able to weave it into this new, very dynamic world of cloud computing. We've talked about the analytics that you can do. We talked about data provisioning, which is really important. There's some other risk management aspects to this as well. I spent a past life moderating webinars for the Global Association of Risk Professionals, or GARP, garp.org. I joke that they are the de facto Illuminati because they're, chief risk officers at central banks all around the world. Of course, there are some banking issues these days. Silicon Valley Bank collapsed. First Republic just collapsed over the weekend. These are very strange times. A lot of people don't understand that all it takes is a psychological event for there to be some run on the bank. And that's what happened with SVB. That's apparently what's happening with First Republic. People are just pulling out massive amounts of money, and that creates systemic risk. So being able to kind of understand that, and especially in this global world where you've got all these different countries involved, you have all these different central banks. Of course, it's all electronic now, so you can access and move money around. A lot of stuff has changed. I mean, the fintech innovation has been absolutely stupendous. And a lot of these banks all have mainframes. They've had mainframes for years doing all this stuff. So I'm curious to know your approach to the risk management side. I can kind of guess just at being able to look into unstructured data, identify entities, basically provide a risk score of some kind. Can you tell us a bit about what you do in the risk management space?
Yeah, well, there's no shortage of opportunities, but also with all opportunities, there's also risks that go along with it. And a lot of the organizations that we serve are very highly regulated too. And so they have certain regulatory obligations that they have around how long they have to keep information. When it's notifications, if a customer asks for certain information, that it can be expunged in a timely manner, and many other things that happen from a process and procedure perspective. And so what happens in that domain is being able to make sure you keep information just as long as you need it, but no longer. And that sounds like it's such an easy thing to say, but it's remarkably hard to do, especially when different classes of information require kind of different retention policies in with that. And then in addition to that, though, certainly retention management is a key thing that our customers think about. But also, as they look to change business processes, use information in different parts of the organization, they need to make sure they have custody over that information wherever it might go. And so what we're seeing more and more is customers are saying, hey, can you make this data available to maybe some business partner or perhaps some internal process? But we need to make sure we have the controls that can see the flow of that information throughout a cycle. Who touched it when? If it integrated with another system, do we have an actual audit trail of the date and time and the proof point that some interaction actually happened? And so that closed loop reporting on that auditing piece is just super important to making sure that organizations are compliant. So when that a regulator comes to you and says, hey, can you show me that paperwork that shows X or Y? The answer is, of course, it's right here.
Yeah. That's a big deal. And, when regulators come calling, you want to have several things in place. It seems to me you want to have your plan, you want to have your architecture documents, and then you want to be able to show the receipts, right? You want to say, well, here's our plan for how we detect breaches. Here's our plan for when we've detected a breach, what we do. Here's what happened in this particular instance, XYZ process is fired off. And then you want to be able to show them in the production system, and here's where rubber meets road. And if you could do all that, you're going to get a lot of leeway. I mean, there's always going to be pressure to improve security, to improve governance, to improve auditability, et cetera. But as long as you have your plan and you're acting on your plan and you're listening to the regulators and what they ask you for, 9 times out of 10, I think you're going to be just fine. What do you think?
Well, absolutely. And what's really important is the full life cycle managed around this. So everything from, like we were talking about at the very beginning, we were saying, hey, this idea of, can you actually go look at the code and see where data is moving throughout your organization? That's actually proving that the systems literally are doing what they say they do, all the way to what happens at runtime, where, hey, this transaction happened on this date, and here's the proof point that it happened, and it's logged in our immutable storage mechanism to be able to have that proof point across the data, but also the processes, the people, and the systems that it interacted with. That's what's really required by many of these highly regulated organizations. And so they look at technologies like ours to help.
Yeah, that's very interesting. You mentioned this a couple of times. So with your software, you're able to look at the code that is instantiated in a particular environment and basically process it. And do you actually run the code, or is it that you just know what it's going to do based upon the functions that you see, and therefore you can look to the log file and kind of triangulate things? Can you explain that a bit more?
Yeah, absolutely. And so what we have these scanners that look at the code that developers have actually in their system, in the version control systems and the actual code itself. And from that, it determines what kind of data is interacted with that one system. And that can be on the mainframe, for instance, as we said, with like COBOL. But what's also interesting is you throughout your organization, you go to other systems and run that same procedure. It might be C++ or Java or some other system. And then the interesting thing is it looks at that, parses that code itself and those entities that are involved, and it sees the connection where one system calls another, and it stitches it together so you can see not just the data in one system and the data in other systems, but you can follow that lineage, that flow of information from one place to another. And again, it becomes an auditor's dream, because when that compliance team says, hey, we want to prove that something happened, you can actually, from a systems perspective, prove where data is touching another system. And as we said, if you want to make business change, again, the compliance officer loves it as well, because you can confidently make changes because you can see the entire data landscape. So it becomes a very powerful visualization around the entire organization.
Yeah, that's really cool stuff. And obviously, you can understand why banks want that level of certainty, because you're moving money around, right? The classic two-faced commit, right? Is, okay, I'm sending money over here. Yes, I've sent it. Did you get the money back? Yes, we got the money back. Okay, good. Like, now we know we can move on and do something else. And wow, you think about the innovation in fintech and how much easier it is to move money around in just seconds and moments. And that took a tremendous amount of back-end work to be able to engage these different systems, to move the money, to categorize it, essentially do all that stuff. That's a big deal, right? And so Rocket Software, I'm guessing, is a significant player in that whole evolution, right?
Yes, and with that, what we've also seen is the ability to scale in terms of looking at these systems automatically and really scaling compliance and other things is super important to be able to get that visibility. But also we found that scaling from a people perspective is super important. And what do we mean by that? Well, if you have that data and it's available to 2 or 3 magicians at your organization that know how to run the magic incantations to tell you what those connections are, that isn't as effective as what if the user experience could be more of a consumer type experience where anyone could go in, see those connections, obviously anyone who's authorized, obviously,
right?
But at the departmental level, or if you're looking to make a business change as a enterprise architect at an organization, you don't have to be that magician to know all of the details of the tool. It really allows you to see those connections that otherwise you would just spend mountains and mountains of time in meetings and manual work to try to achieve the same thing.
Yeah, and not even get to the answer, perhaps. I mean, it sounds a lot like process mining. Maybe we can talk about that in the podcast bonus segment. But that ability to get down to the code level, as you suggest, at runtime, and be able to do the playback. Say, okay, well, here's what happened. This system connected to that system. This data came across the transit, went over here. We can verify that it landed, et cetera. That is tremendously useful information for any kind of troubleshooting, for any kind of improvements. Because then you can look at that at a certain scale and say, okay, we need to change X, Y, and Z to be able to supercharge this one process. You run into the classic impedance mismatch with some of these systems, right? Where it's like, this one is spinning at a certain rate, that one is spinning at a slower rate. How do you get those two to jibe? Basically, that's not a small problem, right? You want to be able to see all that. And your point is that you're able to see into the mainframe and see into these other systems and give a very clear-cut view of which code is enacting it, at what point in time, which data goes in there. That is the audit trail, right?
That is, and really it allows you to make change with confidence. Many organizations, they have the meetings, they have the budget, they have the desire to change, but they really don't know in the end is the thing I've created in my Visio diagram that we had meetings about, is that really how my organization operates? Right. And you just don't have that confidence. And so we help you kind of buy back that confidence in those at change, both from a regulation perspective, but then also just making sure you're effective. Your project's going to be successful.
Yeah. This is wonderful stuff. Well, folks, look these folks up online. Rocket Software. Doug Johnson has been our guest today. We are booking the second half of the year right now. So if you want to be on the show, send me an email, info@InsideAnalysis.com. That comes straight to yours truly, or info@dmradio.biz. We're trying to understand what's happening in the information economy. We'll talk to you next time, folks. You've been listening to Inside Analysis.